In this lesson, we're going to learn how to solve some more difficult equations. Last lesson, we went over how to solve a one-step equation and how to show our working. Remember that we need to make sure that whenever we're showing our working, that we always line up our equal signs, that we make sure that we show the inverse operation on both sides of the equation, and that we always write our final answer in the form of the variable equals a number, just like I've done here. Go ahead and work on solving the other three equations in this first row. Okay, I'll quickly go through these and check that yours looks exactly the same. Since the variable's on the right side, I know I need to undo the minus 9 by adding 9 to both sides of the equation. I'm left with 7 equals g. In the third problem, my variable is on the left side of the equation, and I need to undo the negative 7, which is currently being multiplied by y. To undo that multiplication, I'll divide, which I'll indicate with the fraction bar, on both sides of the equation. This leaves me with y equals positive 13. In number 4, I see that my variable's on the left side and it's being divided by 9. To undo that division, I'll need to multiply. I need to make sure when I multiply, I show that my multiplication is in the numerator on the left side. That way, the numerator and denominator cancel out, leaving me with a equals negative 36. Looking at the next row of equations, these all have a pronumeral multiplied by a fraction. To get rid of a fraction that's multiplied, we are going to multiply by the reciprocal of the fraction. We've learned before that a reciprocal is the multiplicative inverse of the fraction. All we need to do is flip the fraction. So, in the first question, our pronumeral is multiplied by 2/3. In order to get rid of the 2/3, we'll multiply by the reciprocal of it, which is 3/2. This is going to make sure that this fraction cancels out because the 3's cancel and the 2's cancel, leaving me with just x, which is what I wanted. Now I have to remember, whatever I do to one side of the equation, I need to do to the other. So I'll multiply the other side by 3/2 as well. I'm left with x equals 15. In number 6, I need to multiply by the reciprocal of 4/9 to undo it. That would be 9/4. So I'll multiply by 9/4 on both sides of my equation. On the left side, that cancels, leaving me with just x equals, and on the right side, that leaves me with negative 18. Go ahead and try the next two questions. All right, I'll go ahead and quickly complete these. Please mark your work and make sure that you've ended up with the same thing that I have here. In number 7, which I just completed, I needed to make sure I multiplied by negative 5/6. Since the fraction was negative, the reciprocal will be negative as well. The same thing will apply in number 8. I'll multiply by negative 2/1 on both sides of the equation. This is the same thing as just multiplying by negative 2. the fraction on the left cancels, leaving me with m equals positive 18. Now that we are pretty proficient in solving one-step equations and setting up our working accurately, we're going to move on to solving two-step equations. We still have the goal of being able to show our work properly when solving equations. And for these first few problems, I'm going to help set that up for you. So in a two-step equation, the first thing that we're going to want to do is we are going to want to undo whatever has been added or subtracted. We're looking to remove the constant term. After that, then we'll look to undo the multiplication or division and remove the coefficient. Basically, we're working through order of operations backwards. So in the first example, I'll start by drawing my line down the equal sign. I'll identify that my equation, my pronumeral, is on the left side of the equation. And I'll see what other numbers are on that side that I need to get rid of. I see that I've got a 6 and an 8. I'm going to undo the 8 first because I need to undo whatever is furthest away from the variable, which in this case is the 8, and that's being added. So the opposite of adding 8 would be subtracting 8. I need to do that opposite operation on both sides of my equation. So I will subtract 8 on the left and subtract 8 on the right. The 8's cancel, leaving me with 6x equals 42. Now, I'm not finished because I haven't gotten x completely by itself. To continue, I once again want to see where is my value, where is my pronumeral. It's still on the left side of the equation, and there's a 6 also on the left side of the equation that I need to undo. Right now, 6 is being multiplied by x, so I will undo it by dividing by 6 on both sides of the equation. The 6 cancels on the left side, leaving me with x equals 7. Now I know that I'm done because I've completely isolated x. Let's try the next problem. I'll start by drawing my line down the equal sign to help me keep my equations lined up. And I'll start by identifying where the pronumeral is at. It's on the left side of the equation. I also have a 2 and a minus 5. I need to work my way from furthest away from the pronumeral closer in. So I'll start with the minus 5. I need to undo that. The opposite of subtracting 5 is adding 5. So I'll add 5 to both sides of my equation. The 5's on the left side cancel out, leaving me with 2x equals 16. Now again, I'm not done yet because I haven't isolated x. What I need to do now is identify what number is still on the same side of the equation as x. In that case, that's 2. 2 is being multiplied, so how would I undo that? Well, the opposite of multiplication is division, so I'll divide both sides by 2. The 2's on the left cancel, and that leaves me with x equals 8. Now I've isolated x, so I know that I'm done. All right, let's try the next problem. In the next problem, we can draw our equal sign down the line and identify that our pronumeral is on the right side of the equation. So this time I need to undo the -4 and the 9. Which one is furthest from the variable? Again, I'm working my way further from the variable and working my way closer to the variable. That means I need to undo the 9 first. Since 9's being added, I'll do the inverse operation, which is to subtract 9. So I'll make sure I put -9 right under the 9 and -9 on the other side of the equation as well. The 9's on the right cancel, and that leaves me with 4 equals -4x. Now I'm not done. I haven't isolated x. I see that I still have a negative 4 that I need to get rid of on the same side as x. Right now, negative 4 and x are being multiplied. So to undo that multiplication, I will divide by negative 4 on both sides of the equation. When I divide by negative 4, I'm left with negative 1 equals x. Now I've isolated x, so I'm sure that I'm done. Let's try another one like this. We'll start by drawing our line down the equal sign to make sure that our equal signs stay lined up. We'll identify that our prenumeral is on the left side of the equation, and there is a positive 7 there and a negative 3. Which one is the furthest away from the prenumeral? Well, the positive 7 is. Now, notice this is a positive 7. Please don't be distracted by that subtraction sign next to it. That subtraction sign belongs to the 3. The 7 is positive, so if I'm going to undo that 7, I need to do the opposite of a positive 7, and I need to subtract 7 on the left side and subtract 7 on the right side. Now, the 7s will cancel out, and let's look at what's left over. There is a negative 3x left over, equals 27. Now make sure that you don't lose the negative. The negative belonged to the 3, and we haven't done anything with it, so we still have a negative 3x right now. Now the prenumeral is still not isolated. I need to get rid of that negative 3. It's currently being multiplied, so what I can do is divide by negative 3 on both sides. This will leave me with x equals negative 9. Now I've isolated x, so I know that I'm done. All right, let's try a few more. Now the ones below involve fractions, so we're going to need to think about how to undo division and how to undo numbers that are being multiplied by fractions. So let's start with number 13. We'll draw a line down the equal sign. We'll identify that the prenumeral is on the left side of the equation with the 2 and the minus 7. I'm always undoing whatever is furthest away from the prenumeral first. So in this case, that's going to be the minus 7. To undo minus 7, I should add 7 on both sides of the equation. The 7s will cancel, and that leaves me with x over 2 equals 16. Now the prenumeral is still not quite isolated, so I'm not done yet. I need to get rid of that 2 that's on the same side. Right now, it's x divided by 2. So to undo division, I need to multiply by 2, and I'll make sure to put it in the numerator, and multiply by 2 on the other side as well. The 2's cancel, and that leaves me with x equals 32. Since x is isolated, I know that I'm done. All right, let's try another one like this. I'll draw my line down the equal sign to make sure my equal signs line up. I recognize that the prenumeral is on the right side, which means I'll need to get rid of the negative 5 and the 8, since they're on the same side as well. I'll always start with the number that is furthest away from the prenumeral. In this case, that's plus 8. That's the number I need to get rid of first. The opposite of adding 8 is subtracting 8. So I'll subtract 8 on that side and subtract 8 on the other side. The 8s will cancel, and that leaves me with 3 equals x over negative 5. Now, I'm not done. The prenumeral is not isolated just yet. Right now, it says x divided by negative 5. So to undo that dividing by negative 5, I need to multiply by negative 5, making sure to put that in the numerator, and multiply the other side by negative 5 as well. The negative 5's cancel, And that leaves me with negative 15 equals x. Since x is isolated, I know that I'm done. All right, we've got two more. So I'll start by drawing my line down the equal sign. I can identify that the prenumerals on the left, I need to get rid of the numbers on the left. So the 3/5 and the 22. I'll start with the one that's furthest away from the prenumeral, which is the plus 22. To undo that, I'll subtract 22 on both sides of the equation. And that leaves me with 3/5 x equals 6. Now, I need to still keep going. X is not isolated. I need to get rid of that fraction. Now, we did this problem up above, and I'll scroll up for just a second. Remember that to get rid of a fraction that's multiplied, we can multiply by its reciprocal. So in this problem, we can multiply by 5/3, and whatever we do to that side, we have to do to the other side as well, and multiply by 5/3. The 3's and 5's cancel, and we're left with x equals 10. Since I've got x by itself, I know that I'm done, and I've found the solution. All right, last one, same process. Draw our line down the equal sign to keep our prenumerals lined up. Identify that the prenumeral is on the left side, which means we need to get rid of the negative 1/3 and the plus 1. We'll start with whatever is furthest away from the prenumeral, which is plus 1. So to get rid of that, we'll start by subtracting 1 on both sides. That cancels out the plus 1, leaving me with negative 1/3 x equals negative 8. Now to get rid of the fraction, we'll multiply by the reciprocal. So the reciprocal of this fraction is negative 3/1. And we'll multiply by that reciprocal on both sides. The fraction on the left cancels, leaving me with x equals positive 24. I know that's my answer because I've isolated x, and if I were to substitute 24 into this equation, it would make the left-hand side and the right-hand side have the same value. So if I check my work, I can see at this checkpoint below that I have lined up my equal signs vertically. I have shown my inverse operations on both sides. I have boxed my solutions, and I've made sure that my solutions are written with the variable equals the number. So my working is good, and now I can also solve two-step equations. Go ahead and continue with the practice on the other side of the page, making sure to follow these exact same principles.